Electrical codes, including the National Electrical Code, commonly require a minimum wire size of American wire gauge number 2 copper or its equivalent for subpanels. They also specify a minimum conduit size of 1 inch for American wire gauge number 2 copper conductors. The connection point for the incoming feeder cables is often required to be at least 6 inches outside the subpanel enclosure. Copper buck connectors are generally not permitted for connecting feeders to subpanels. The National Electrical Code specifically prohibits the use of pressure connectors for conductors larger than American wire gauge number 8 copper. Several options exist to address the issue of the existing feeder wires not reaching the connection point in the new subpanel. Firstly, you could extend the feeder run. This involves hiring a licensed electrician to disconnect the power and extend the American wire gauge number 2 feeder cables from the main panel to the subpanel. This is often the most straightforward and code-compliant solution. Secondly, consider installing a larger subpanel. Purchase a larger subpanel that provides a connection point for the incoming feeder cables at least 6 inches outside the enclosure. This eliminates the need to extend the existing feeder wires. Thirdly, it's possible to install an additional subpanel. In this scenario, you would install a smaller subpanel with the feeder size that can accommodate the existing American wire gauge number 2 cables. Then connect a second subpanel downstream to provide the additional circuits needed. Extending the feeder run is often the most recommended solution because it ensures the subpanel is properly connected and meets all safety requirements. It's critical to remember that electrical codes can vary from state to state, as well as locally. It's always best practice to consult with a licensed electrician or your local building inspector to determine the specific requirements for your area. This consultation ensures compliance and safety in your electrical installation. The National Electrical Code sets standards for electrical safety that are widely adopted. However, local jurisdictions may have amendments or additional requirements. This is why consulting local experts is essential. In extending a feeder run, it's important to use appropriately sized junction boxes and connectors that are rated for the amperage and wire size involved. Ensure all connections are properly torqued to the manufacturer's specifications. When installing a larger subpanel, verify that the new panel has sufficient capacity for the intended load and that the main breaker is properly sized to protect the feeder cables. Consider the available space and mounting requirements for the new subpanel. When adding a second subpanel, make sure to calculate the total load on the existing feeder cables to ensure they are not overloaded. Properly size the feeder cables and overcurrent protection for the new subpanel. Also, ensure adequate working space around both subpanels for future maintenance and repairs. When extending the feeder, the connections need to be accessible, and you cannot bury connections in the wall. It is important to maintain separation of high and low voltage wiring. If the subpanel is located in a damp or wet location, use an M3 or rated enclosure. When dealing with electrical work, always prioritize safety. Turn off the power at the main breaker before working on any electrical components. Use appropriate personal protective equipment, such as safety glasses and insulated gloves. If you are not comfortable working with electricity, hire a licensed electrician. Improper electrical work can be dangerous and can lead to fires or electrical shock. Verify the voltage rating of all components to ensure they are compatible with the electrical system. Use only listed or certified electrical equipment that meets industry standards. When running conductors through conduit, use the correct size and type of conduit for the application. Ensure the conduit is properly supported and secured. Avoid sharp bends in the conduit, as this can damage the conductors. When pulling conductors through conduit, use a lubricant to reduce friction. Do not exceed the maximum fill capacity of the conduit. Properly ground the subpanel enclosure to ensure electrical safety. Use a grounding conductor of the appropriate size. Connect the grounding conductor to a grounding electrode system, such as a ground rod or water pipe. Use appropriate bonding techniques to ensure all metal parts of the electrical system are properly connected. Properly label all circuits in the subpanel to identify their function. Use a circuit directory to record the location of each circuit. Keep the circuit directory up to date. When replacing a circuit breaker, use a breaker of the same type and amperage rating. Do not use a breaker with a higher amperage rating, as this can overload the circuit. Regularly inspect the subpanel for any signs of damage or deterioration. Look for loose connections, corrosion, or overheating. If you find any problems, have them repaired by a licensed electrician. Keep the subpanel clean and free of debris. Do not store anything in front of the subpanel that could obstruct access. Ensure adequate ventilation around the subpanel to prevent overheating. The National Electrical Code Article 310.15 provides guidelines for ampacity of conductors. It outlines the allowable current carrying capacity of various wire sizes and insulation types under different conditions. These tables help ensure that conductors are not overloaded, preventing overheating and potential fire hazards. The National Electrical Code Article 250 covers the requirements for grounding and bonding. Grounding provides a path for fault current to return to the source, tripping the overcurrent protective device and preventing electrical shock. Bonding connects all metal parts of the electrical system to create a low impedance path for fault current. The National Electrical Code Article 408 addresses switchboards and panel boards. It outlines the requirements for the construction, installation, and overcurrent protection of these devices. Panel boards are used to distribute power to branch circuits. The National Electrical Code Article 110 provides general requirements for electrical installations. It covers topics such as working space, guarding of live parts, and identification of equipment. Proper working space is essential for safe maintenance and repair of electrical equipment. Consider the use of surge protection devices to protect sensitive electronic equipment from voltage spikes. Surge protection devices can be installed at the main panel or at individual branch circuits. Regularly test ground fault circuit interrupters to ensure they are functioning properly. Ground fault circuit interrupters are designed to protect against electrical shock by detecting small leakage currents. Consider the use of arc fault circuit interrupters to protect against arc faults, which can cause fires. Arc fault circuit interrupters are designed to detect dangerous arcing conditions in electrical circuits. Consider the use of energy-efficient lighting and appliances to reduce energy consumption and lower utility bills. Energy-efficient lighting and appliances can save money and reduce the environmental impact of electrical usage. When disposing of old electrical equipment, follow proper procedures to ensure it is recycled or disposed of safely. Old electrical equipment may contain hazardous materials that can contaminate the environment if not handled properly. When working with electricity, always be aware of the potential hazards and take appropriate precautions to protect yourself and others. Electricity is a powerful force that can be dangerous if not handled properly. The overcurrent protection of a circuit is designed to protect the conductors from overcurrent. Overcurrent can be caused by an overload or a short circuit. The overcurrent protection device, such as a circuit breaker or fuse, is designed to trip and interrupt the circuit if an overcurrent occurs. The size of the overcurrent protection device must be properly matched to the ampacity of the conductors. Using an overcurrent protection device that is too large can allow the conductors to overheat and potentially cause a fire. The neutral conductor carries the unbalanced current from the load back to the source. The neutral conductor must be properly sized to carry the maximum unbalanced current. The grounding conductor provides a path for fault current to return to the source. The grounding conductor must be properly sized to carry the maximum fault current. When running multiple circuits in the same conduit, the ampacity of the conductors may need to be derated. Derating is required because the heat generated by the conductors can raise the temperature inside the conduit, reducing the ampacity of the conductors. The derating factors are specified in the National Electrical Code Article 310.15. When installing electrical equipment in a hazardous location, such as a flammable or explosive environment, special precautions must be taken to prevent ignition. Hazardous locations are classified according to the type of hazard present. The National Electrical Code Articles 500 through 516 provide requirements for electrical installations in hazardous locations. Electrical equipment used in hazardous locations must be specifically designed and approved for the location. Consider the impact of harmonics on the electrical system. Harmonics are non-sinusoidal currents and voltages that can cause problems such as overheating of equipment, increased energy consumption, and interference with electronic devices. Harmonics are typically generated by nonlinear loads such as electronic ballasts, variable frequency drives, and computers. Harmonic filters can be used to reduce the level of harmonics in the electrical system. Properly maintain the electrical system to ensure its safe and reliable operation. Regular maintenance should include inspecting equipment for damage, tightening connections, and testing overcurrent protection devices. Keep records of all maintenance and repairs. Consider the use of a qualified electrical contractor to perform electrical work. A qualified electrical contractor has the training, experience, and equipment necessary to perform electrical work safely and correctly. Check the contractor's license and insurance before hiring them. Obtain multiple bids from different contractors before making a decision. Always obtain a permit before starting any electrical work that requires a permit. Permits are required to ensure that the work is performed in accordance with the electrical code. Inspections are performed by the local building department to verify that the work is code compliant. Keep a copy of the permit and inspection report on file. The National Electrical Code is updated every 3 years. It is important to stay up to date on the latest code requirements. The National Electrical Code is available for purchase from the National Fire Protection Association. Consider attending electrical training courses to improve your knowledge and skills. Electrical training courses are available from various organizations, such as trade schools and community colleges. Continuously learn and improve your knowledge of electrical systems and safety practices. Electrical technology is constantly evolving, so it is important to stay current in the latest developments. Joining a professional organization, such as the Institute of Electrical and Electronics Engineers, can provide access to valuable resources and networking opportunities. When troubleshooting electrical problems, start by identifying the symptoms. Then, use a systematic approach to isolate the cause of the problem. Use appropriate test equipment, such as a multimeter or clamp meter, to measure voltage, current, and resistance. Follow safe electrical practices when troubleshooting electrical problems. If you are not comfortable troubleshooting electrical problems, hire a qualified electrician. The purpose of the electrical system is to provide safe and reliable power to the loads. The electrical system must be properly designed, installed, and maintained to ensure its safe and reliable operation. By following these guidelines and consulting with qualified professionals, you can ensure the safety and reliability of the electrical system. These practices help to mitigate risks and ensure compliance with applicable codes and standards. Furthermore, regular inspections and maintenance are crucial for identifying and addressing potential issues before they escalate into major problems. Proper documentation of all electrical work, including permits, inspections, and maintenance records, is essential for future reference and compliance purposes. When selecting electrical equipment, consider factors such as energy efficiency, reliability, and environmental impact. Choosing energy-efficient equipment can help reduce energy consumption and lower utility bills. Selecting reliable equipment can minimize downtime and maintenance costs. Considering the environmental impact of electrical equipment can help reduce pollution and conserve natural resources. When installing electrical equipment, follow the manufacturer's instructions carefully. A proper installation can avoid the warranty and create safety hazards. Ensure that all electrical connections are tight and secure. Loose connections can cause overheating and potentially lead to fires. Protect electrical equipment from physical damage. Use appropriate enclosures and guards to prevent damage from impact, vibration, or moisture. Provide adequate ventilation for electrical equipment to prevent overheating. Overheating can damage electrical equipment and reduce its lifespan. Regularly clean electrical equipment to remove dust and debris. Dust and debris can accumulate on electrical equipment and cause overheating. When replacing electrical equipment, use only approved replacement parts. Using unapproved replacement parts can void the warranty and create safety hazards. Dispose of old electrical equipment properly. Follow local regulations for the disposal of electronic waste. Consider the use of renewable energy sources such as solar or wind power to supplement the electrical grid. Renewable energy sources can reduce reliance on fossil fuels and lower carbon emissions. Consult with a qualified electrical engineer to design and install renewable energy systems. The design and installation of renewable energy systems must comply with applicable codes and standards. Consider the use of smart grid technologies to improve the efficiency and reliability of the electrical grid. Smart grid technologies can monitor and control the flow of electricity, enabling more efficient use of energy. The National Electrical Code Article 700 covers emergency systems. Emergency systems are designed to provide power to essential loads during a power outage. Emergency systems must be tested regularly to ensure they are functioning properly. The National Electrical Code Article 701 covers legally required standby systems. Legally required standby systems are designed to provide power to essential loads that are required by law to have backup power. Legally required standby systems must be tested regularly to ensure they are functioning properly. The National Electrical Code Article 702 covers optional standby systems. Optional standby systems are designed to provide power to non-essential loads during a power outage. Optional standby systems are not required by law. Electrical safety is a shared responsibility. Everyone has a role to play in ensuring the safe use of electricity. Be aware of the potential hazards of electricity and take appropriate precautions to protect yourself and others. Report any electrical hazards to the appropriate authorities. By working together, we can create a safer electrical environment for everyone. Always remember to de-energize circuits before working on them. Verify the circuit is de-energized using a reliable test instrument. Use lockout/tagout procedures to prevent accidental energization of circuits. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Maintain a safe working distance from energized equipment. Never work on energized equipment unless you are properly trained and authorized. Follow all applicable safety regulations and procedures. If you are unsure about any aspect of electrical safety, ask for assistance from a qualified professional. Remember, safety is always the top priority. These guidelines emphasize the importance of adherence to established codes and standards, ongoing education, and the adoption of safe work practices to prevent electrical hazards. Regular inspections and maintenance are vital for identifying and addressing potential issues before they escalate into serious problems. By embracing a proactive approach to electrical safety, you can significantly reduce the risk of accidents and ensure the reliable operation of electrical systems. Consistent application of these principles contributes to a safer and more efficient electrical environment for all.